Okay, hello and welcome to today's Technical Steering Committee. We will take a look at the proposal from Dimitar about the Spegel support in the Registry cache extension. We will start again, as usual, with a short recap of the most important part by Dimitar, and then followed by a larger block of questions and general feedback toward the proposal, and then in the end, we follow up with a decision concerning the proposal. So with that, Dimitar, I hand over to you.
Okay, thanks, Johannes. I will share my screen. Okay. Hope my screen is visible.
Yes, it is.
Yeah. Okay, then I'll start with the motivation. So why we decide to go into this direction and to search for a different cache solution. So our current solution is based on distribution projects pull-through cache, and we see that it's not widely adopted, at least in landscapes that we operate, and we also know that it has some limitations. So some of them are listed here, but this one is important. Actually, we could not cache Amazon ECR registries using this solution. So we also have problems to cache most of the images for pods in Cube system namespace. We also know that Dynatrace registry also has problems, and it's actually not compliant, and for some layers it returns content like 0, so we fail to cache these layers. We also have limitation because we can define only one credential set for upstream registry, and you may have several private registries, and actually you can define only one set of credentials. Okay, so why should we care? It's because of cloud cost mainly, and also if we do something, we can reduce image pool latency as well. So the idea in this proposal is to provide image cache solution that could be enabled by default for all shoot clusters. So if we do this, then we can reduce the cloud costs and, of course, reduce the image pool latency. Yeah, for the proposal, we want to use peer-to-peer image cache based on Spegel. Spegel is, I would say, amazing project because it's lightweight. Actually, the code base is not very big, but nevertheless, it provides functionality to cache actually all of the images that we have. So maybe I should skip this introduction to the Spegel and Kademlia projects. Maybe if there are questions, I will answer them later. So the API, So we will start with a simple API and with only 3 settings. You can redefine registry port, router port, and metrics port. And we will choose actually different default values, not the one that you see here. But yeah, when I write the document, I didn't consider that we have to choose carefully these default ports. So with the architecture overview, here I give an example that operators can enable this extension type by default. And here is the overall architecture. Okay, in the control plane, we will have Spegel bootstrapper that will define bootstrapper nodes that are needed for Spegel during startup, and maybe later it also could be used if there is conditions for active bootstrapping. Let's say that the node loses information in its routing table, then he will switch to this active bootstrapping process. So here in the shoot cluster, let's have one node, and kubelet wants to pull an image. So yeah, I forgot first when Spegel is starting, it start listening for image events in the container D, and also initially it advertise the content of all already existing images in the container D image store. Yeah, let's now the kubelet wants to pull an image. It sent pull image request to container D. In the container D default on the default host toml configuration, we have configured Spegel as first host entry, and container D will ask Spegel to pull the image. So if the image does not exist, the container D will respond with not found 404, and then a container D will pull the image from the upstream. So now let's have another node, and the kubelet on the node 2 wants to pull the same image. Then it will send again a pull image request to container D, and a container D will send this request to Spegel. Spegel will search for this content in the peer-to-peer cluster. It will find that this content is already existing Spegel on node 1, and here will get this content from the Spegel 1 registry and stream it directly as a response to container D. Then container D will send the event that this image is created, and the Spegel 2 will also advertise this content in the peer-to-peer cluster. So actually the same is valid for any other nodes. but yeah, in this case, it will pull different image layers from different nodes. Okay, so in the current proposal, the Spegel is run as systemd unit. There is also a systemd unit that scrape the metrics from the Spegel metric export and write them to the node exporter text file collector. So container deconfiguration, we make sure that this carton pack layers is false, because otherwise the image original image layers will be deleted after the image is unpacked, and so we will not be able to serve this content anymore.
Dimitar, can we come to
speed up
the questions? Yeah, a bit.
Yeah. Okay. So actually, this is the overall architecture here, and yeah, we can go to the questions.
Okay, then thank you, Dimitar.
Should I go through these comments here, or you will just ask?
I mean, I don't know. We have never done it so far like that. So I think maybe if any one of you have already some general questions or comments, let's start with that. We can.
I collected some of the most interesting questions from my side. I guess we should prioritize them this way. So one question was about the node exporter's text file collector. So in the proposal, there's a script exporting metrics, if I get it correctly. So my question is why we can't scrape the Spegel components directly like we usually do with system components running in the chute.
So to be honest, I actually take this the way I collect the metrics is the same as in the RCSWalk extension. So Puamen introduced this text file collector, and I actually implement the same approach here in the Spegel extension type. If there is a better way, then I can rework this part actually, but to be honest, I don't know whether there is other way to do this. So if you know how, yeah.
Dimitar, you're saying that the node exporter running in the kube system namespace cannot scrape the metric export of the unit on the hosts, right? This is what you mean?
So I'm not sure whether it's not possible. I'm telling you what I saw in the RCSWalk extension, and I do the similar here in the Spegel. If there is a better way, then maybe I should check this.
I think for usual pods, we basically do the ordinary scraping so that Prometheus or Blackbox exporter is scraping directly the pod endpoints. Now the Spegel extension or Spegel is running directly in the host network, I assume.
Yes.
Then you don't really have a pod. That being said,
yes.
we have also node export. We also have a couple of pods running kind of in the host network and sometimes going directly via the nodes to scrape. So that's, I guess it is possible to still scrape Spegel also directly via Blackbox exporter. I think it's also possible here via node exporter, moving it via the text file. So I assume we have, if you say so, it's already with the AirSys log extension, we have apparently more than one approach to do things. So I don't see the real trade-off, what is better or worse, but I think there are different approaches. And I think I understand that Tim is confused by this, because I also was initially a little bit surprised. Let's put it like that.
Yeah, actually, for the registry cache, the metrics are directly scraped from the Prometheus. But here, I didn't know how to do this, and I see how it is done in RCSWalk. So I do the same here.
Okay, thanks for clarifying. I suggest trying out scraping directly, whether it's possible, and then we can probably take a decision from there. I was wondering about one sentence in the document about changes required in other extensions that inject registry configurations. Yeah. So did I get it correctly that other extensions doing so need to comply with the Spegel extension, or explicitly support that?
Not exactly, but let's say in a different way. So at the moment, when registry cache wants to configure a registry for some upstream, it will create this host Tomova file, and if there is something existing for it, it will completely delete the whole information and recreate it from scratch. So if we want to inject Spegel host as a first entry here, then maybe other extensions that configure containerd registries, at least they should not delete what Spegel configures here, and the other way is also valid. So Spegel should not delete what is already configured. So this is what I mean here. That we at least we need a change in registry cache, and as far as I know, the same is valid for image rewriter extension.
So did I understand correctly that Spegel is directly modifying the host files on disk, or
No.
would the extension inject the mirror configuration via the OSC?
There is an API in OSC, and all extensions are using this API. But yeah, at least in the registry cache, we will recreate this entry, this configuration. So if Spegel first adds something, then after that registry cache, we will completely delete it and add its own configuration.
Yeah, so you're meaning that if you have multiple webhooks, basically mutating the entity and always saying, okay, I want to be first, and yeah. So in that sense, basically all the entities or the entities need to play fair together.
Yeah, exactly.
Okay. Now I get it. Probably mentioning the order of webhook mutations in the document would help understanding your point.
Okay.
And just to add a few sentences about it before we finish this topic, I think we cannot avoid this because, for example, we want to support also Spegel to be enabled together with the registry cache, and we want to implement that first. The first entry to be the Spegel. First check if any of the nodes in the cluster has this image. If not, fall back to the registry cache, the pull-through cache in the cluster, and finally fall back to the upstream registry. Yes, and that's why we need this ordering, and we also have one more actor, as Dimitar mentioned, the Garner image writer extension. At the time of writing this, this extension simply ignores, I think, does not mutate if there's already entry for that upstream, so that it doesn't fight with the registry cache extension. So we also have to adapt this extension and need to find an order about it in the list of the mirror configuration.
Actually, we discussed this once with Tim Usner, that if we introduce Spegel, then we have to change something in the image rewriter.
Okay. Cool, got it. One more clarifying question from my side is about custom bootstrapper. So my understanding is that if we run the Spegel components as a systemd unit, we can discover the peers, and that's why we need a custom bootstrapper, and the one from upstream doesn't work. Is that correct?
Yes, exactly. So currently, Spegel provides several bootstrappers. The simple one is static, where you can define stable nodes, the IPs of the stable nodes. The one that is used by default, this is the DNS bootstrapper, and in this bootstrapper, it make headless DNS lookup for the service behind Spegel daemon set, and in this way it took the addresses of all nodes where Spegel is running, and it is alphabetically sorted, and first three entries are returned so that the new Spegel node can join the peer-to-peer cluster. Actually, there are other node discovering mechanisms. At least I try to use the multicast DNS with the local step. Unfortunately, it didn't work because on Macs we have this Bonjour protocol running on the same port. 5353 is the port by default. And later on, I checked that most of the IaaS providers does not support multicast, and yeah, I dropped this as an option.
Okay, got it. Any questions from the others?
Yes, we just talked about the bootstrapper, so I think we discussed this also in the comment. But just to be clear, so if the community, which actually seems to be only one person, right? So
yes,
doesn't accept this, we have a problem with the whole proposal. So we cannot do something out of tree. We need this HTTP bootstrapper in.
Yes, actually, we need this if you want to go into this direction, that deploying the Spegel as systemd unit. So maybe I can say a few words about this, why we choose to run Spegel as a system D unit. So first of all, it's closely coupled with containerd because it reuse the containerd image store. It listens for containerd image events, and it feeds the containerd running on other nodes with content. And so in the long term, we can even include Spegel in machine images similar to containerd, and maybe with some default configuration, so that node agent can also benefit this, and because currently there is a limitation. Actually, the images that are pulled by Gardner node agent and the Gardner node agent image itself cannot go through Spegel registry because it's very early point in the node creation. So there is no Spegel when Gardner node agent pulls images. This is why we decide to go into this direction.
Yes, I mean, I understand that. I just want to, this was not too clear in the document that the whole proposal cannot be implemented if this one person does not accept our contribution there. And that might be a problem. I mean,
what can still be implemented is deploying it via daemon set, just like the hand chart does, right?
Yeah.
And I would like to challenge whether the system D approach is actually the right one. I see many drawbacks in it. For example, we don't have visibility in Kubernetes, so we don't know the component is running there. We have no auto scaling for it. We would need to take special care for optimizing the resource requests, or even decreasing the allocatable node capacity if it runs there. We can't just do label-based scheduling, like if users want to disable it for certain worker pools and so on and so forth. So also debugging gets easier, right? If it runs as a pod, you can just port forward and so on and so forth. So what would be missing to get it early onto the nodes would be to have it included in this node lifecycle, right? There's the taint managed by the resource manager's critical components controller. The system components like kubeproxy and so on don't or tolerate this. Maybe we can consider an alternative where we hook into this life cycle and ensure that Spegel is running before starting all the other pods, all the other system components. That might be possible from what I get. We just need a design for how to hook it into the controller.
But how would the peers then be found if this would be run as a daemon set?
If it runs as a daemon set, it will use the default bootstrapper, which is the DNS bootstrapper, and this way it will get the bootstrapping nodes. So this is the standard Spegel deployment.
Which DNS name would it try to resolve to get the peers?
I think it's a headless service in the kube
Headless
system
service. Yeah.
which resolves to
So it means
the
it needs
IPs of
needs
the
core DNS,
And
which
thereby it needs
needs
kube
pod
proxy.
network, which needs a lot of things. So that I mean essentially means it cannot start very early on the first node.
Yes.
On the second node and so on, it's no problem, but it's a question what we want to optimize.
So on the first node, it doesn't matter because anyway you should pull these images from the upstream. So
it's just a bootstrapping problem. So I mean, if it tries to get the DNS name, it cannot get it. It will not get an answer because core DNS is not running.
Okay, but this is only on the first node.
Yes.
Right? Yeah. Okay, then. So what the Spegel recommends is using this controller, and it also taint nodes and the daemon set will tolerate this taint, and this way you can deploy Spegel first. And so in this case, we always pull the Spegel and the pause images from the upstream, and also all the images that Garner node agent pulls. There is no chance to go through Spegel. So actually, with this proposal, it's also only the kubelet will pull all the images through Spegel registry, but then the node agent will not. But as I mentioned, long term we can provide the Spegel with the machine image. I think that it's too early to include it because there are a lot of changes still. It's not mature enough to include it, I think. But whatever we take as an approach, it will be much better than if we do nothing. Because, as I said in the beginning, the adoption of the registry cache is not good.
For me, the question is how much we want to optimize here at what cost. So making sure Spegel runs early on and almost all images are pulled through it is a high bar, is a very high goal in my opinion. And the cost is that we lose all the benefits of running it as a daemon set, for example.
By the way, sorry for interrupting. I agree with you, Tim. And but what about running as daemon set and using an external bootstrapper? Demeter, would be this an option? Because we only talked about the built-in DNS bootstrapper, which is a headless service.
Yes. So if we want to run Spegel as a daemon set, then I think we should use this DNS bootstrapper.
No, I mean, not the bootstrapper that depends on core DNS, but the one the generic HTTP bootstrapper. I mean,
generic
that contacts to the control plane component.
Yeah. So if we run Spegel as a daemon set, we don't need this external bootstrapper.
No, I mean that, but we just talked that if we use this built-in bootstrapper, then we cannot cache a lot of many of them. Okay, yeah, but what if we use this HTTP bootstrapper? Can we still cache? And just imagining that we have the approach that Tim explains with the taints.
no, if we use this approach with the TENS, we can cache almost everything without Spegel and pause image, and without images that are pulled by the Gardener node agent. So if we decide to go into direction that we deploy Spegel as a systemd unit long term, when we include the Spegel into the machine images, then I think we can cover everything.
But about this proposal about including Spegel to the machine images, I don't know how realistic is this, because we can have...
It's not part of this proposal because I think it's too early to this. So it's not mature enough.
Yeah, we can have some influence in Garden Linux, but not in Flatka or Ubuntu or any other OS, what they shipped or what they start by default or not.
Yes. But we can include it into the Garden Linux images.
Okay, but let's keep that aside. I think for me the more interesting question here is because I see different opinions here. Do we actually have an agreement that the daemon set approach versus the systemd unit approach is the better one, or I feel that we have basically we can gain more visibility, more of the usual Kubernetes tooling with the daemon set approach. If we really want to cache more images, it might make our node setup a little bit more complicated because we have to first set tains, run Spegel, and when that ready is, then we continue with the rest. So nodes might come up a little bit later, or it might take a little bit longer until a node comes up. But it's still possible, and it's still kind of a trade-off. You could still argue, okay, we bring Spegel up just in parallel to all the node critical components, meaning that the node critical components cannot be cached, but everything else can afterwards be cached. And we still have a very easy, convenient way to have registry or have a cache, a container cache in the landscape where we don't have the maintenance, or also the cluster owners don't have the maintenance to configure all the registries for individual caches, which apparently limits our adoption currently with the existing solution.
Yeah, the same is also valid if we can, if we contribute this external bootstrapper and deploy Spegel as a systemd unit. So maybe, yeah, we can lose some Kubernetes visibilities, but anyway, it's more close to containerd, and containerd is systemd unit. It's not daemon set, right? It's container runtime.
Yes.
Yeah.
But all the other concerns get more challenging, right? Like getting the right amount of resources to it, no auto scaling, no monitoring by default.
So actually, I think that here from Johannes there was a question or maybe concern about this memory usage. So actually, initially the Spegel process uses around 45 megabytes of memory. So the memory high is set to 18 megabytes. And at this point, if we have some page cache because we will stream we will have probably intensive IO operations at some time when we stream the image. So this cache will be collected, and I hope that we can fit into 100 megabytes of memory. But to be honest, I didn't test this on large clusters. So maybe we have to check this. So the assumption is that the memory consumption as well as the CPU consumption will be relatively constant. Because here in the DHT, the keys are these digests, image digests and node IDs, which is actually they are public keys. They are 32 bytes. The length is 32 bytes, and the value is the address of the node. Here, some multi-address concept is used, and there are maybe IPv4. It will start with IPv4, then the IP, and then the port. So the content is not big. So I assume that the memory will be relatively stable, and also not all digest will be distributed to the all nodes. Only one part will, only the closest nodes to the digest will keep this information.
Okay, let's maybe ask the other way around. So if we deploy a new component to all the nodes, we should ensure that if it is crash looping, we can observe this via the shoot conditions, right? The shoot system components.
Mm-hmm.
Just like for the registry cache extension, for example. How would you implement that?
So how it is implemented for kubelet or for containerd node agent? So in the similar way, I will implement it in a similar way. It's also this open telemetry collector. I think it's also unit, systemd unit.
Okay, but all of these components are managed by Gartner itself, so not via an extension. And at least I'm not aware of any mechanism that you can contribute health checks to the Gartner node agent. So this would need to be covered.
I mean, it could be possible. We could extend basically Gartner node agent to check the systemd units, which are contributed. So any extension could contribute a systemd unit, and then Gartner node agent can check on the systemd units to see that it's not crashing all the time. Probably this information you can get from systemd.
Probably.
That's something, I mean, that's kind of a generic way you could implement it. I'm not sure. I doubt it is done that way right now. I think for kubelet and for containerd, that's more or less explicit checks, right?
Mm-hmm.
But I mean, a general check would make sense. So that.
Yeah, what I'm basically saying is that all of this might be possible, but it's not all considered in the proposal right now. So the consequences of running as a systemd unit can probably be covered, but we would need to spec all of this out. In the end, for me, running as a systemd unit sounds like yeah, it is a trade-off between simplicity and efficiency, right? So caching more versus simpler deployment via daemon set. But in the end, Spegel still is a best effort cache, and eventually nodes will need to pull a new image and so on and so forth. And we can't expect, or shoot owners can't expect, that via some magic we can cache everything. That's not how distributed systems work, right? We can optimize a lot, and if we do it via the daemon set, we will have optimized quite a lot from what I get. So this is a huge improvement, and I'm wondering whether we should rather start there before going so deep into the magic tricks.
Tim, I would be okayish with your proposal for the daemon set approach, but I recall we had similar discussions also with the registry cache extension when we talked about the same, and I think there I'm not sure how you imagine to introduce an order in the daemon set scheduling and so on, because right now we have only the not critical taint contract, right? So first the not critical components run, and after that the rest ones. So we have to introduce such a contract for an extension, so we can instruct the Spegel daemon set to run first, and after that, if you want to cache all the kubeproxy Calico daemon set images, we need these daemon sets to run, and after that the rest of the daemon set pods. And yeah, if you are fine with delaying the node creation a little bit, I assume this sequential order will delay it a little bit, but maybe not that much. If you're fine with this, and if we manage to find a good contract, then why not?
Yeah. You're totally right. So this is also probably these are more steps in optimizing, right? So the first step would be just marking it as node critical, so that Spegel runs before all of the workload pods. That would be a great optimization already. So probably 80% of what we want to achieve. And then we can optimize it further to make it start even further or sooner, like before kubeproxy, if that's even possible. I don't know. Yeah.
Okay, but let's say that with this approach, we won't be able to cache images that will be put on each and every node. I mean that node agent already pulls several images plus pulse image. Yeah, it's rather small, but it will be pulled several times in parallel, because there are parallel requests pulling this pulse image. At least this is what I observe in the logs, and also the Spegel image itself. So this will happens on each and every node. So these are data that will go through the nuts, and this is cloud costs at the end of the day. And so yeah, I'm also okay with both approaches, but I think that with the one proposed here, with some further steps to extend this, and so maybe not in all machine images, but at least in Garden Linux, I believe we can include this into these images, and we can actually cache these images as well. And yeah.
Dimitar,
So
by the
yeah.
way, we showed the nodes images we can cache now. I mean, the ones pulled from the node agent.
No, with this proposal, none of the images that are pulled from Garden are not agent.
Then I mean, if we make Spegel running as daemon set pods, like if we have some means in Gardener to first run the Spegel daemon set pods, then the rest of the daemon set pods, then it is the same. We can.
I'm just thinking about what images are left if we run Spegel as a daemon set pod before all the workload pods, because all images that are pulled before that are coming from a single registry, probably the one that the Gardener landscape operator brings, right?
Yep.
So in that case, probably those images are best cached externally, so meaning via the registry cache extension in a dedicated volume, right? So if you start a cluster and cache the volumes.
Sorry, but registry cache unfortunately cannot be used at this point of time because it can be used once the kube proxy runs, and service that is up from the registry cache stateful set is accessible from the node.
It needs a pod network again and DNS.
Yeah, it needs a services network.
Service network, yes.
To be configured.
Okay.
Okay, I don't want to interrupt all the discussions. I think they're helpful. That being said, I think we're actually in the decision time, and I think the decision would rather be to have another meeting, right? To discuss further or continue the discussion on the PR and then maybe come to a conclusive meeting. Does that make sense?
Yeah, maybe it makes sense.
Yes, of course.
So
question
to hear
would
some
be
feedback from you and the other steering members about their feeling on the systemd unit, or if that's rather a concern that only I have.
So I think just to share my thoughts on this, I think I can understand that there is a trade-off, basically. The trade-off is, what do you want to achieve? Do you want to cache as much as possible? And obviously, if you want to cache everything, then it needs to run directly in the beginning. And that might actually be really hard, because then you might need to change actually the Linux distribution, which might be possible for us for Garden Linux, but might not be possible for Flatcar or someone else. So I think that's obviously a trade-off. And then it goes in the direction of, okay, do I really need to cache the node agent? Yes, it is downloaded everywhere, but maybe I can also live with some images not being cached. If at least, I mean, under the assumption we have a lot of workload images that might actually be bigger, so that might actually may be more traffic. So if our images are the majority of the traffic, I anyway wonder why there is a Kubernetes cluster there. So my hope is that the more important stuff comes after us. And then it kind of goes in the direction of visibility, as you mentioned, Tim. I think we already have already a couple of systemd units, so it's not like we would go a completely new route. And it is sometimes difficult to figure out that something goes wrong there. because we don't have good visibility into those things. So if Valitail fails for whatever reason, you might figure it out very late after the fact and then figure out, okay, for example, I don't have logs anymore. So there, a daemon set might be better. So it's kind of, yeah, depending in which direction you want to go, I can understand both,
But this is
both
probably
ways.
something we can independently improve, right? So with the health checks in Gardner Node Agent for general system D units, I think this is something we could do. So I would also not be so concerned with the system D unit approach, because as also listed here, there are also others that we already run, and it's not something completely new. But I think it makes sense to discuss this a bit more, and also the alternative with the daemon set, so that it's clearer for everybody what would be the consequences of both approaches. Maybe one more last point, so about caching these images here. As far as I understand, this is only for the very first pull, right? So once Spegel is set up and we do a Gardner update, have maybe a new node agent image, then this is cached, right? Unless the node is completely replaced, of course. But for such things where you roll out new versions of these components in place, it's still useful.
Yes, actually, at least the first image should be pulled from the upstream container. You will pull this image from the upstream,
sure.
And probably if you update several a set of nodes in parallel, then maybe most of them will pull the image from the upstream, because the image should exist in container image store, and after that the content will is advertised to other nodes, and then you can use Spegel to pull the content from Spegel registry.
Yeah, but we cannot optimize much better than that, right? So
yes,
let's not discuss that. Okay.
Okay, but how shall we continue? Sorry, Raphael.
One more clarifying question, maybe. So even with both the unit or the daemon set approach, we still rely on this HTTP bootstrapper, right? Because even with the daemon set, we need some peer-to-peer finding mechanism that is not depending on kubeproxy and others.
Depends on when we want to run them. So if we just mark it as not node critical, it might run after kubeproxy, and then we can reuse the default behavior of Spegel. This is basically the first step that we could take right away without any adaptations in Core Gardener or Spegel, and would already improve probably 90% of the caching, the image pools. And as you said, even the updated images after the node creation.
And this would also resolve a lot of the problems that we would have with the bootstrapper, right? This is something that needs to be deployed. You talked about MTLS and stuff. This all needs to be managed somehow, and if we don't have all of that, it will be much simpler, of course. So yeah, probably it makes sense to outline this approach and what are the consequences.
Yes, if we go to direction to use daemon sets to deploy Spegel as a daemon set, then we don't need this external bootstrapper. And yeah, the disadvantage here is that not all of the images can be cached using Spegel.
I feel like we should take this first step that we can take right away without much complexity and rather invest some time into measuring the efficiency of the solution. And if we see bigger gaps that we still want to optimize, we can think about optimizing them whether using the outlined approaches that have more complexity, but maybe then we will have a good justification for whether it's worth it or not.
Yeah, maybe. So I actually didn't try to run Spegel using this controller to taint the nodes and to tolerate this system critical components. And didn't try this. I could, and I can also try what Spegel is recommending, this need hook controller. I can also try this, but the decision is yours. So I'm also okay with this because the situation will be much better than now. So it's also an option.
Okay, now I wonder, do we reach an agreement here or do we need a follow-up?
No, I think the decision is yours. So
yeah, the question goes to Tim and Raphael.
I think
okay.
for now we didn't reach any agreement, right?
Okay.
We just reached uncertainties.
Okay. Fair enough.
Yeah, okay.
I think in general this proposal will be very valuable and most of the aspects are clear, but all of the uncertainties rather come from this particular question: how much do we want to optimize and what costs do we take? And yeah, as suggested, we can start with the first step, deploying it as a daemon set with low complexity, measuring the efficiency, and then we can go step by step further down the line, optimizing the hell out of it. Probably this is something we can agree on now. If not, then we should take another round.
As I said, I'm okay with both approaches, so the decision is yours.
I would say that we take another round because there are pros and cons. I see value. I see reasoning like in Tim's proposal, but implementation wise, I think it would be hard to implement.
Yeah.
I mean, if we decide to go from the daemon set to Spegel, I think it would be much more effort if we just started with the system unit approach since from the beginning. And I don't know what if we run Spegel as daemon set after the not critical components, then this means that we cannot cache our system components, and we cannot reduce the image flow costs.
We cannot cache them for the first pull. So I mean, it kind of depends whether we have long-running nodes.
Yes.
And people patch, for example, their Kubernetes patch releases, each one.
Yes.
And basically the first one is not patched and not cached on each node, but the second one is. So it's, yeah, if they throw away nodes all the time, so in certain scenarios where you rotate all the nodes, for example, our Pro cluster rotates nodes quite heavily, it might not be perfect. Then again, I mean, we also have a lot of workloads there, so maybe it is. I don't know.
Yeah, we also have one prominent stakeholder, which creates Okay.
Yeah, but I think, as now said multiple times, I think it would be helpful if this approach is discussed as one option that we could go for. That is maybe less costly than this other approach with the systemd unit plus the bootstrapper contribution plus everything that comes with it.
Mhm.
So yeah, and there I think it's valuable to check if it's really worth to invest so much compared to a cheaper solution that maybe is also good.
So actually, if we talk about contributions, so there is another thing that we also plan to propose, where it was next steps. Yeah, here we can also try to contribute this an option for topology awareness routing so that we can reduce the cross-zonal traffic as well. But yeah, this is future enhancement. It's not on the focus now.
Okay, but what kind of timeline do you have in mind? So if we want to, if basically the assumption is let's try think about the daemon set approach versus the systemd unit approach, take that also experiment with it, bring it into the proposal as well, so that we have a clearer side-by-side comparison also.
Yes, if we have a follow-up meeting after maybe next week, then I could try to try this approach with deploying Spegel as a daemon set. And for this, the first 2 points, so I think that I will need 1 person day for to file a PR with this external bootstrapper, and for the productization of the POC, maybe we will need around maybe 40% days to make this production ready, because at the moment there are no unit tests, we don't have end-to-end tests, and so on and so on. So for these first 2 steps, maybe something like maybe 40% days, including the PR reviews, because it also takes some time.
Okay, I'm a little bit confused. I thought now we're talking about timeline for the next discussion, not necessarily productization.
No,
so should we meet tomorrow, or should we meet in next week, the week after, and so on? So just
let's not decide this now. Let's just update the document. Everybody reads it again asynchronously, and then we see what is needed.
Yeah, fair enough.
Yeah, please take your time to try out the other idea. Probably have another POC with it, and outline both approaches in the document along with pros and cons, and then we can have another iteration and a final decision.
Yeah, okay.
Okay, perfect. Then
nice.
Thank you very much, Dimitar, for the proposal. Thanks everybody for the discussion. Let's discuss offline and continue the online discussion at a later point in time.
Okay, thanks.
Sounds good. Thank you.
Thank you.
Bye.
Bye.
Bye.